Another type of data that you might want to display to understand better we call grouped discrete data. So this is still discrete, but compared to simple discrete data, there's more different values, and we want to make it simpler. So for example, this time we're looking at LeBron James' 2015-16 season, in which he led the Cavs to victory in 7 games against the 73-9 Warriors. And so if we're just looking at the points that he scored in each game, regular season he played in 76 games, playoffs he played in 21, we have a lot of different points. Okay, so we've got 97 different games in which he played, and not only are there a lot of different games he played, there's a lot of different values of points that he scored. So if we were to do the same thing that we did with simple discrete and make a different frequency for 0 points, 1 point, 2 points, 3 points, 4 points, and so forth, it would look pretty messy. And even if we graphed it in a column chart like we did before, let's see what it looks like. Now we can see, yeah, this is roughly symmetric distribution. We can see that the mode is 26 points, but you notice that it goes up, down, up, down, up, down, up, down, up, down, and that doesn't really give us a good sense of what his overall trends were. Okay, so if we look at each individual possibility as its own separate column, it might be very confusing like this. So let's keep the overall shape. Let's show how to do grouped discrete data and see if the overall shape is still the same, but maybe it's a bit easier to understand. So as you might understand from grouped discrete data, we're going to take the discrete data and group it. We're going to choose different intervals, meaning like a range of numbers, and we're going to look at how many times he scored in that interval or in that range of points. The important thing about these intervals is that they're equal length, meaning I'm not going to do like 0 to 1 point, 2 to 5 points, 6 to 100 points. They need to all be the same width or the same length so that we can evenly look at how the points are distributed across those different ranges. So in this case, I'm going to do the length of 5, or 5 possibilities in each one, so 0 to 4. So anything in here where I scored 0, 1, 2, 3, or 4 points. And the next one, it's got to be the same length. Start at 5 right above the last exit, the last upper value, up to 9, 10 to 14, 15 to 19. So you see each one ends in a 4 or 9. I'm going up by 5 each time. And I'm breaking it up this way, one, because a lot of people like multiples of 5, but also this gives us a reasonable number of bars or groups to look at. So I'm going to look at this set of data first and see, well, I've got to start at 0, even though he never scored less than 12 points, just to be complete because 0 was a possibility. And the highest he ever scored was 41, which he did twice. So I need to go up to include 41 in there. So at this point, I would do the same thing as I did last time, go through one by one. Well, 25 is between 25 and 29, 12 is between 10 and 14, 29 is in this range, and so forth. In this case, I'm going to save you the time of having me do this for the next 5 minutes and just tell you how much each range is. Okay, so now, once I have the frequencies here, they're not for individual point values. It's not like he scored exactly 15 points 9 times. They're grouped. But once I have the frequency column here, I can plot it exactly the same way as before. And so I would make charts the same way I did before and fill it in as before. I'm just going to show you what that looks like here. This one, I did this on a computer, but this one is your 0 to 4. This one is your 5 to 9, 10 to 14, and so forth. You see there's one column or one bar for each of these different intervals or different groups. And so now we can see there's not the weird up, down thing going on. It's just more smooth, and it looks like that. Okay, so let's compare this overall trend, which was already very smooth, to what we had before. We can see it's roughly the same shape. The mode is in between 25 and 29, and it's roughly symmetric. It's not perfect. Maybe it's slightly negatively skewed, but it's pretty symmetric, and we get a better sense of what a typical game for LeBron was in the season, usually between 20 and 29 points, without it looking really choppy like it did on the right side over here. So grouping data, even if it's discrete, is a good way to get a better sense of what the data are actually saying, what the data overall look like, so that you have a better understanding when there are more different values that could possibly happen.